Hello, everyone. My name is Sharon Rosina Wamalwa, and this is my Kenya Maize Prize forecasting dashboard that I developed as part of my data mining for competitive advantage course at the University of South Dakota. This dashboard, as you can see, is built to support proactive food security planning across 5 Kenyan counties by forecasting maize prices up to 12 months into the future. So, what was the problem or the challenge that I was addressing while building this dashboard? Maize is Kenya's primary staple food. When prices spike, low income households are hit the hardest. Historically, governments have reacted to food crises after they occur. So, this dashboard will change everything in that it will be able to give planners who work in agricultural or food departments early warning signs so that they can pre-position food reserves and target assistance before a crisis develops, and it is tailored per county. Now, my data source, it's coming live from the World Food Program Kenya Food Price Dataset. It is hosted on the Humanitarian Data Exchange. The app fetches this data live every time it loads. So it always shows the most current prices. Today, it shows data up to February of 2026. Now, on the dashboard, we have the dashboard, the focus table, about. So here you can select the county you want. I focused on 5 major counties. Why did I focus on these counties? I wanted agricultural county, which is Uasin Gishu, arid and semi-arid counties, Marsabit and Turkana, and urban counties, Mombasa and Nairobi. So with this county, I can choose, let's say I'm choosing a county like Nairobi. Then the best model, and I had done an analysis. So each county was able to pick the best model. We have different models such as naive, ETS, ARIMA, and the time series linear model. So for Nairobi, it's going to choose the best model for the analysis that I used, and then it's going to forecast up to 12 months. Once that, I generate the forecast. If I want, I can refresh the live data. The chart, it shows the full price history all the way from 2006 to today. With the forecast shown, the forecast is shown as this dashed green line going forward. The shaded bands, these shaded bands that you can see, are the confidence intervals. The wider that they are, let me move this so that you can be able to see. It's this part and this part. It's a very interactive dashboard, as you can see. So the wider they are, the more uncertainty they are in the forecast. The dotted lines show our warning and critical signs. Here they are. And everything is explained below on the dashboard. Now, moving on slowly, on the top, you can be able to see the current price of maize per kilogram in Nairobi. It's at 51.11 Kenya shillings. The average forecast, this is the expected percentage change, and it also gives you historical data, 242 months. This counts all the way from 2006 to current. Now, let's go to the forecast table. The forecast, this is the predicted maize price per kilogram for that month. We have the lower confidence interval of 95%, the upper, also upper 95%, and the statuses. The statuses are put such that if it's green, it's safe. This shows that price is within the normal range. The yellow warning, I use this as most of us, we know yellow is for warning signs, even on the road signs. Price is getting high and it should be monitored. The red one is critical, shows price is at a level likely to cause food insecurity and it requires immediate action. From the focus table, we can be able to see that Nairobi, all the way to February of 2026, is safe, as prices will be getting, the focus column shows 50.45. Now, This forecast column, as you can see, shows our best estimate of the price. The lower 95% is the best case scenario, going to 32, 33, all the way to 33.36. And then we can also see that there is only a 25% chance price that will fall below this. The upper, which is the 95%, is the worst case scenario for planning purposes. The status column, it uses, as I had explained initially, different colors for us to know if you're in the safe, if you're in the warning or in critical, just to ensure we plan properly. Now, moving on in the About section. So About gives the user just some information for them to be able to understand what is the dashboard all about. So it explains the objective of the dashboard. So it says this dashboard was developed to support proactive food security planning across 5 Kenyan counties. And it also explains the problem that the dashboard is trying to solve. It also gives you the data set, which is from the World Food Program, Kenya Food Price Dataset on the Humanitarian Data Exchange. This is something you can confirm. Why I chose the 5 counties, as I had explained earlier. The forecasting models that I use. So we're going to put a little bit of focus here. So 4 models were trained and evaluated on 20 years of historical maize price data. Each model was tested on the last 24 months of the data it had never seen before, just to make sure that I avoid overfitting of my model. So why do I have the best model recommended? When you go to the dashboard, you'll be able to see that forecasting model have the best model and the other model. So all this is explained in the About section. So this automatically uses the model that performed best for the selected county based on our analysis. For Nairobi and Turkana, it was the time series linear model. For Marsabit, Mombasa, and Uasin, Gishu, it was the naive model. Then the naive, this is the simplest model. It was our benchmark. It uses the last month's prices to predict this month's prices. Then you have the exponential smoothing. This gives more weight to recent prices that occur recently, like maybe in 2024, 2023, than the older ones in 2006. Then you have ARIMA. It uses the pattern between a month's price and the previous month's price. Then finally, the time series linear model. It fits a straight line trend through the historical maize prices and adds monthly seasonal adjustment. So this is just to briefly explain to the user of the dashboard what the model simply means. Then finally, it explains why it is forecasting up to 12 months and also best model per county and the warning size. So I worked on this project for a whole semester, from data collection, data cleaning, programming using R programming language and R Studio, learning some of the libraries I use, using Shiny to be able to upload and launch this app to be officially on the website. My instructor who guided me through the project was Professor Thomas Tihat, and this project is part of the coursework I do at the University of South Dakota. So it's publicly accessible at sharonrosina.shinyapps.io/maize forecasting, and the R code is fully available on GitHub. I'll put everything, all the links down below. Feel free to go through the dashboard, uh, play around with the interactive dashboard, play around with the different counties. Tag me in the comment sections below anything I need to improve, and if you want to collaborate on any project from me. Thank you so much for watching. Bye bye. Bye.